We are going to work on solving some additional trigonometric equations. We'll start with this one, secant squared x plus tangent x minus 3 is equal to 0. Notice that secant squared x and tangent x are two trigonometric terms, and they are not the same function. We want to make sure that we have everything in the same function. We can, however, use the trigonometric identity that tangent squared x plus 1 is equal to secant squared x. This changes our equation to tangent squared x plus 1, making that substitution for secant squared x, plus tangent x minus 3 is equal to 0. When we combine like terms, we see tangent squared x plus tangent x minus 2 is equal to 0. In case you need a refresher, we could write this as y squared plus y minus 2 is equal to 0 just by letting y equal tangent x. We can factor this into y minus 1 times y plus 2 is equal to 0. So let's go back to our problem where we were using our tangent x. This means that tangent x minus 1 times tangent x plus 2 is equal to 0. We can set each of these factors equal to 0. So if tangent x minus 1 is equal to 0, tangent x is equal to 1. Looking at the unit circle, we see that that's going to happen somewhere in quadrants 1 and quadrants 3. And in fact, this is going to happen whenever y equals x on my unit circle. So we know that theta has to be 45 degrees or pi over 4. So x will be pi over 4. It will happen again pi units later. You can see this is exactly 1/2 of a rotation. So it will happen at 5 pi over 4. The general solution for this part, so general solution, would be x is equal to pi over 4 plus pi n. Remember, it's pi n because we're talking about tangent, which has a period of pi. Now let's look at the other part, where tangent x plus 2 is equal to 0. This means that tangent x is equal to negative 2, and our answer is going to be the arc tangent of negative 2 is equal to x. Using your calculator, you can get that x is equal to negative 1.1. Again, we define our arc tangent function on the interval negative pi over 2 to pi over 2. We can see that it will be somewhere down in here, which means our other one will be somewhere up in here. Let's make these positive. That's the best way to do this. So if we take pi minus 1.1, that's going to be approximately 3.14 minus 1.1, which is approximately 2.03. Our next one happens pi units later. So we get 2.03 plus 3.14, which is approximately 5.17. If I wanted to write this using a general solution, I would get 2.03 plus pi n radians. And again, that's because the period of tangent is pi units. I'm going to now solve a different equation. 9 sine x plus 3 is equal to 5 cosine squared x. Again, we are not using the same trigonometric functions as seen with sine x and cosine squared x, but we can make a substitution. We know using our Pythagorean identities that cosine squared x is 1 minus sine squared x. Remember, you will need to then distribute this 5 to both parts of that term. We'll be left with 9 sine x plus 3 is equal to 5 minus 5 sine squared x. I can add 5 sine squared x to both sides. So I get 5 sine squared x plus 9 sine x plus 3 minus 5 is equal to 0. If I've combined like terms, the result is this. Now, I can factor this just as we did before. In fact, it factors into sine x plus 2 times 5 sine x minus 1 is equal to 0. So let's look at each part. If sine x plus 2 is equal to 0, then sine x is equal to negative 2. We know that this is not possible because our sine function only reaches 1 and negative 1. So negative 2 would be down here and it would never intersect the graph. So this does not exist. Let's look at the other part. If 5 sine x minus 1 is equal to 0, then sine x is equal to 1/5. Making sure that you are using radians this time. And that's because we have a interval from 0 to 2 pi. We can take the arcsine of 1/5. Keep in mind, the arcsine function is defined in the first quadrant and the fourth quadrant. When we do this, we actually get 0.2 radians. So our first angle in quadrant 1 is right here. Our second one is going to be right here, but we would need to find that. Notice that in quadrant 2, all angles are less than pi. Our second angle, so our first one is x equals 0.2 radians. Our second one is going to be pi minus 0.2 radians, which is going to be approximately equal to 2.96 radians. Assuming that we use the approximation, pi is approximately equal to 3.14. Please remember to watch the videos on verifying trigonometric identities, and I will see you on Monday.